Building knowledge graphs from your text documents. Hello everyone, and welcome to our channel. This video is on something called knowledge graphs and why they are such a big deal. Specifically, we'll cover: what is a knowledge graph? What is the difference between knowledge graphs and traditional databases and spreadsheets? What are some applications of knowledge graphs? What are the challenges of creating knowledge graphs? How can you build knowledge graphs by extracting text from your documents using GPT-5 or other powerful LLMs like DeepSeek, Claude 4.1, or Grok 4? And we'll give a practical example using Neo 4j LLM Knowledge Graph Builder. So let's get started. Imagine you could take a novel of 1,000 pages, a set of news articles, a blog post, and a Wikipedia page, and instantly transform all this information into a visual map that shows how everything is connected. All the relationships between characters, events, plots, etc. are connected visually. That's essentially the main idea behind knowledge graphs. Presenting all your data in a knowledge graph, which can help you uncover hidden connections between complex topics, track relationships between people and things, and spot patterns in the information. Building a knowledge graph from unstructured text used to require a lot of manual labor or complex machine learning models. But with the advance of AI and large language models nowadays, it's getting easier than ever before. In this presentation, we're going to cover the concept of knowledge graphs, what they can be used for, and also show you how to turn any text document into a knowledge graph using large language models, such as OpenAI's GPT-4o and GPT-5, or even open-source large language models that you may prefer like DeepSeek 3.0. In the end, we'll develop a small web application that can generate smart and interactive knowledge graphs from any text. This can be a powerful tool that not only helps you make sense of complex information, but also reveals connections you might have missed. What is a knowledge graph? A knowledge graph is essentially a structured representation of entities and how they relate to each other. You can think of it as a massive mind map that gives you a bird's-eye view of how people, places, things, and all the concepts are connected to each other by clearly defined relationships. As an example, we'll take the TV serial Game of Thrones. It is probably one of the most effective examples to show what knowledge graphs are. We'll use a knowledge graph to get an overview of the key characters, their relationships, how they're connected through romance, friendships, alliances, rivalries, and battles. So at a single glance, we'll be able to see who's connected to whom, who is plotting against whom, and how all the major storylines intersect. Differences to traditional databases and spreadsheets. You might be wondering, how does a knowledge graph differ from a traditional database or spreadsheet? In both these cases, information is stored in tables with rows and columns. But this flat list of things quickly becomes impractical when dealing with complex relationships. A graph structure, on the other hand, organizes data in a network of nodes and edges, where each node represents an entity like a person, a place, or a concept, and each edge represents a relationship like this person works with or lives in, or this thing is a type of. So this obviously is much more efficient and more visual. But the best part is that you can perform various mathematical operations across different portions of the graph too. Depending on the use cases, you might decide to calculate things like the shortest path between the nodes or identify the most influential nodes in the network through centrality measures. Or you can also even detect clusters of related nodes using community detection algorithms. Applications of knowledge graphs. Knowledge graphs are already being used in many areas, from improving fraud detection to search engines and even drug discovery. Google's knowledge graph. Around 10 to 15 years ago, Google realized that knowledge graphs can significantly improve search results compared to solely relying on matching keywords on user queries. If you've noticed that every time you go to Google and search for a person or item, for example, John Kennedy, you see an information panel on the right that shows the main information about him and all the related people, his spouses, children, the place where he was born, and the titles and position he held, and even the organizations he worked for. These results come from a massive knowledge graph built by Google, which is a massive database of millions of facts about people, places, and things. This knowledge graph helps Google return accurate, factual, and highly relevant results for your queries. In fact, with advancements in Google's Gemini large language models, soon we'll see Google's knowledge graph linked to their world models and ontology, to beef up AI to near human-level cognition or artificial general intelligence. Graph RAG, Retrieval Augmented Generation. Knowledge graphs have proved to boost the accuracy for retrieval augmented generation applications, or RAG. This is a common technique and application of generative AI for answering user queries on private large datasets, such as corporate internal document archives and databases, including ERP transactional SQL databases. Traditional RAG systems retrieve data for users' query, which works well for straightforward questions. But when a query is complex, like connecting events across different multiple documents and databases, the traditional RAG systems can struggle to provide accurate answers. That's where the Graph RAG approach comes in. Here's how it works. First, it constructs a knowledge graph from the source documents, identifying the key entities and their relationships, and this graph is then used to create a bottom-up clustering that organizes the data hierarchically into semantic clusters. This clustering allows for a more holistic understanding of the dataset. Whenever someone asks about an entity, for example, NVIDIA, from all the different sources, it may identify that NVIDIA is an entity in the knowledge graph from the source documents. Then it will retrieve all the different pieces of information related to NVIDIA. And so this approach allows the LLM to ground itself in the graph instead of only relying on keywords or semantic similarity, and therefore it can return the most relevant results related to this entity. Another example is when a user query requires a higher understanding. For example, this query: what are the top 5 themes in the data? The results using the Graph RAG approach can retrieve the most detailed and relevant themes with the power of semantic clustering feature. Other applications. Another good use case for knowledge graphs is fraud detection. Graphs can help detect transaction fraud rings and other sophisticated scams by looking at entities, people, accounts, and transactions performed by and between them. In drug research and discovery, knowledge graphs are helping with storing and analyzing complex relationships and interactions between drugs, diseases, symptoms, genes, proteins, and so on. And in education, knowledge graphs are positively impacting learning and study. Once you create a mind map for learning a subject, for example, that includes all the concepts you need to know and how they're related, the absorption of knowledge and understanding can be streamlined. Knowledge graphs effectively turn an otherwise boring textbook into an interactive learning experience. Why was it challenging to create knowledge graphs? You might also wonder, if knowledge graphs are so awesome, why haven't we been using them all along? Well, before the rise of advanced language models, building a knowledge graph was quite a time-consuming and difficult. It required days, even months of human effort and domain expertise to extract entities and define their relationships accurately. Creative developers come up with rules to do that, but all rule-based methods were highly inflexible and unscalable. And this was true even when natural language processing techniques and machine learning models started appearing and improving. They could only do the work to a limited extent. Machine learning models most often only worked well with English language because this is the language they are most trained for, and they often struggled with nuances, context, and the ambiguity in human language. But thanks to modern AI and transformer-based large language models that can read and understand multiple languages, can process large volumes of text, and now also have reasoning capabilities that allow to extract entities and map the relationships in a much more automated and faster way. Quick experiment: Neo4j LLM Knowledge Graph Builder. To see how easy it is to create a knowledge graph, even if you don't know how to code, we will use the LLM Knowledge Graph Builder from Neo4j. Here is the website, llmgraphbuilder.neo4jlabs.com. You must first sign up with them and obtain a Neo4j instance. After getting an account, you can download your Neo4j credentials. This is all for free. Next step is to upload document as a text file and generate and preview the graph. All the information is extracted from the text file that you input into this graph. So from such a simple text, we can construct quite a good overview of the stuff that and relationships. You can see that all the different colors here are all the different types of nodes. That is a quick look of how a knowledge graph might look like on a small example. This is an interactive graph where you can zoom in, zoom out, hover on the nodes, and filter the nodes and relationships. It's very simple, just with a few lines of code. In conclusion, let's recap those key takeaways. Transformative power. We've seen how knowledge graphs turn messy, unstructured text into a clear web of connected insights. Advantageous structure. They're simply on another level compared to rigid tables, enabling truly powerful and flexible data analysis. The LLM revolution. And best of all, modern large language models have demolished the technical barriers, making this technology faster and more accessible than ever. Final thoughts. Tools like the LLM Graph Builder are putting this power directly into your hands, allowing you to build these graphs without writing a single line of code. So whether you're a researcher analyzing data, a developer building the next big app, or just a curious mind exploring complex relationships, knowledge graphs can provide you with truly unprecedented insights. The future isn't just data-driven, it's interconnected. We hope this video sparked some new ideas on how you can use LLMs to convert your text into powerful knowledge graphs. If it did, do us a huge favor. Smash that like button if you found this useful. It really helps us out. And subscribe to the channel for more content that breaks down complex tech into practical, actionable ideas. We've got a lot more coming on LLMs, AI tools, and data visualization. We want to hear from you. What kind of text data would you want to turn into a knowledge graph? Let us know in the comments below. Thanks for watching, and we'll see you in the next one.